What's up, guys? This is Hussein Nasser from iGeometry, where we discuss software engineering by example. It's 9 p.m., but I thought, yeah, why not? Let's do an episode. So this is our regular series where we sit down and open the text editor and code. We're coding on JavaScript API for ArcGIS. We're building a map viewer. Generic map viewer that lists almost works with any ArcGIS server instance. So today I was thinking, be a run start. Today I was thinking I would do something hardish. It took me some time to figure out, to be honest. So let's just get to it here. So it's like today we're gonna do projection. So it might be worth to talk about projection and spatial references. So when we create data sets, a feature class in ArcGIS, we have the option to specify a spatial reference, and that spatial reference will determine the accuracy based on my location. So where my data lands, I basically have a special spatial reference for almost all regions, and there is this unified spatial reference, which is WGS 84, the web Mercator, which is for the whole world. Okay, I'm not an expert per se, but in general it gives you more accuracy to give certain areas, right? So for example, Naperville has a special Naperville has a special Illinois, Naperville, Illinois has a special spatial reference. Bahrain has a spatial reference. Abu Dhabi has a spatial reference, and that gives you different coordinate system, right? And different x and y's along and latitude. And so what you want to do is how do you project different coordinates from a spatial reference to another spatial reference? And the bug that we've been seeing here for a long time is when I like load the water network, for instance, which is on Naperville, Illinois, it is working off a particular spatial reference, which is come on, man. It is spatial reference. That's the spatial reference for Illinois, state plane, Illinois, P, whatever, right? So what I'm trying to say, I think, is every service that you're gonna publish or consume will have a different spatial reference. It might have a different spatial reference. And all the base maps that we consume has a single spatial reference, which is, I think, WGS 84, which has a specific well-known identifier, which is known as a wicked. Yeah. So, for example, all right, guys, sorry about that. Yeah. So, what we want to do here is let's go to the USA, for example, and if I go to JSON and I took a look at the spatial reference, this is the default spatial reference, which is the 4326, and that's the web Mercator essentially. And that if that matches your base map, then you will be allowed to basically project and work with this data set. You can essentially put your data on top of that map. If that doesn't match, you'll get like weird result, like what happened here, right? Nothing happened. All right. So the question is, how can I take the existing extent or coordinate or envelope that is projected using a specific spatial reference and reprojected kinda to the default spatial reference, which is in this case 4326, and that is called projection in general, right? So this is what we are trying to do here, and today we're going to write a function, a generic function that takes any service, pull out the full extent of the service, project that full extent into the web Mercator, and then zoom essentially to that full extent. So that's what we're trying to do today, guys. Let's get to work. So to do the projection, we will need some help here using something called a geometry service. Geometry service is published as a utility function with almost every ArcGIS server has it. So if you go to your services, utilities, you'll find this puppy right there. There is a function called project, right? So as you can expect, the function takes as an input a spatial reference. It takes, okay, this is your input spatial reference. What do you want to export it to? This is the output spatial reference, and what geometries essentially you want to export. And you can just leave these as default. We don't really care about them. So this is what we're going to do today. Let's go to my water network here, and then let's open the water network, and I'm going to project this spatial reference, right, which is the water network spatial reference, right? That's the input base there. And I'm going to project it to this 4326, which will be hard-coded in our code, right? And for the geometries, we're going to cheat here and see how are we formatting this. So we're going to essentially format it in this way. So this is an object which takes a geometry, which takes a geometry type. What is the type of that? And then the list as an array of geometries. Very simple stuff. So I didn't memorize that, so I'm gonna copy it and paste it here. But these points are incorrect, obviously, right? Because I'm gonna give it two different points, right? Which takes us to our next thing here, the full extent. The full extent is just an object, right? An object that has 2 points essentially. A full extent is basically has x-men. Let's go to a map showing you that. A full extent is essentially 2 points drawing a rectangle essentially. So this is concerned, you can see my mouse here. So this is the x-men and the y-men, right? And then x-max and y-max. So this is x-men, y-men, x-max, y-max, right? And that will basically, this 2 points presents the full extent. Very simple. So I need to take these 2 points and convert them into essentially a 4326 projection. Let us do this. So x-men, y-men. That's the first point. X-max and y-max. And then let's go ahead and project, and look at that. We got a nice geometry with 2 points corresponding. This point correspond to the first one, and this point correspond to the second one. Look that good. But now, let me show you here in the debugger that when I do map view dot extent, this is how you set the extent for the current map view, equal the layer. Do I have a layer? We can do a map. We have a map, yes, and it has layers. And the first layer essentially is the service that we're loading, which is water network, and that dot full extent. If I do that, that usually works, but look at what we're getting, right? That's what essentially what you need to do to set the full extent. But look at the error we're getting. Incompatible spatial reference. So we now are responsible to build our own full extent object with those projections. So how about we do that, right? So if I took those 2 points and built a new spatial reference, essentially, spatial reference, a full extent out of that, I will be able to work this out. So what is a full extent? Full extent is an object of has a lot of stuff right here, right? But what I'm gonna do is I'm gonna declare my own object here, fe, and then I say xman is equal to, guess what, guys? That's our xman, remember? fe dot xmax or ymax, ymin equal to, that is the converting one, fe dot y xmax is equal to, obviously guys, you know we're not going to do this by hand, we're eventually going to code that, but you know me, by the time you're watching episode 28, you know me that I like to do things, clarify things before I code. And there we go. We have our xmax, ymax, all that stuff, good stuff. Does this have spatial reference? It does, so we're gonna do that as well. Alright, let's do that. Now, let's try that. I don't even need to set a spatial reference. Look at that. Guys, did that work or what? That is Naperville. That is Naperville. Beautiful. Beautiful. So we got it to zoom in, right? So all we have to do is simulate whatever we did here in code. Are you guys ready to do some code? Let's do this. Code, code, code. Open. Alright, so we need to write a function called the project and zoom. And what does this take? It takes a full extent, which is the unprojected one. And essentially, we need to make a request. Correct, guys? So we need to make a request. We need to get the spatial reference of the input, but let's make a request first, because that's a full-on request here, right? So to make a request, we need to steal that request object that did we do a request before here? Must have done a request here. There you go. That's a request. Looks like a request to me. Alright. Let options equal response. Not only that, we only want a response type. We also want to query. Right? A query is an object that also tells you like what are you sending here exactly. So we're sending JSON as a format. We're also sending these puppies, input spatial reference. So remember guys, I taught you how to do that stuff, right? So This is not the actual parameter to cheat. You can just inspect here. You can see that it is actually NSR. That's the parameter. And that is an input spatial reference, which we don't know here, which actually we can get it from the full extent dot spatial. But there is a trick here, guys. We cannot send objects here to the input. We need to convert them to a string. This is essentially a JSON object, and we need to stringify it. So you just needed to do that. Full extent. Just make it into a string. And out is R. I cheated here. I know this is called out is R, so we can just hardcode that safely, because I know all base maps are 4326, so that's good. What else, guys? This is interesting now. This is also supposed to be a string. And what is that property? It's called geometries. So geometries, we're sending geometries as, again, as a JSON string here. So although you're sending a JSON object, remember guys, you need to stringify it. Stringify that thing. This is hard-coded. We can leave it as a point. This is geometries. This is not always that number, right? You guessed it, guys. This is full extent.xmin, full extent.xymin, xmax, ymax. I have no idea if this is gonna work from the first time, man. That would be genius if that worked from the first time. That would be genius. Alright, gonna request that thing. And when we receive a response, what are we receiving here? We're receiving a response. What are we gonna do with the response, guys? We're gonna zoom in. So map view dot full extent equal response. We need to build our own shard. We're gonna build our own. Out of this puppy, we need to build the full extent object, right? Just like with fe. F equal this, fe.xmin, exactly like we did here, guys, with the debugger. fe.xmin is equal. This is interesting, guys. This is called so response is the actual response. Data is the actual data. This is just the esri request. So you have to say dot data to actually get that data. Right, so let's just call this D. And then D dot, this is D dot geometries, right? And since geometries is an array, so I want the first element dot X. That's X-min. And what's the Y-min? You guessed it. And how can I do the X-max? X-max, Y-max. This is 1. This is 1. And all we have to do is F8. I have no clue if this is gonna work or not. Project and zoom. Last thing, when we build the talk, when we try to go to, which we will comment out this will not work, remember, because of the incompatible spatial reference. What we're gonna do is project and zoom, and we need a full extent, which is this guy, our lovely function. Will that work? Oh, wait a second, guys. Did we specify the URL? We did not. Sir, That URL also hard-coded, by the way, guys. The sample server is available. It's at our service, so we can safely use it. I think so. But you can repoint this to, for example, configure this to point to your service. If you don't want to hit that publicly available geometry service, you can just point it to your local ArcGIS server. If that doesn't make any sense, guys, please just comment in the YouTube section, comment section below. YouTube section. Wow, the whole thing is a YouTube section. All right, refresh. Holy shit, I don't think it worked. Oh my! What happened? Water network. Okay, we're debugging, nice. Uh-oh, does that crash? What are we doing here? Okay, we're stringifying that thing, which essentially is this. If it doesn't find request, did that work? So nothing happened. Maybe I'll add a catch here, guys. Error alert error. If that request failed, maybe let me know. That's what it says. Right. Let's put an error here. Holy. That is not really on. That's weird. Okay. Alright. Interesting. So that told me this didn't even okay, URL is that, options are those, and the latest widget is input. Okay, that's okay. Alright. Looks like, was it successful? Put a breakpoint here in the response, so it's successful or not. Oh, look, it's successful. Alright. What is this? Data, we got geometries. Nice, so that actually worked. Data, D equal this. Data geometries. Alright. We get a nice value. We get a nice value. We get a nice value. And that's our zoom in. Looks like that worked. Okay. How about water network? Alright. Worked. Oh, guys, look at that. No, it is okay. X-min, Y-min, X-max, Y-max. No, that's okay. Sorry about that. Got excited there for a second. Alright, that is if E. Looking good. Y-max. Let's. Alright. Really expected this to work, so I don't know why it's not working. Oh. Let's try this. Fe.spatial reference is equal to this. Like that. Work. X and Y. The geometries of the zero will be X, Y min, X, Y max, and then set map view to full extent equal Fe. Sounds legit. We're editing the same project, right? That's good. So we're still zooming on San Diego here. Let's just move to other network. Do the trick. Alright, let's take a closer look. So we know this works because we did it manually. We projected everything manually. We got that. We got the insert, outsr, we got the geometries. We sent that, we stringified. We send the geometries, and we send the xmin, ymin, xmax, ymax, and we said let's go to Wi-Fi. Request. Can we do that? Alright, so we got the result back. Oh, what the hell? What are you talking about, dude? Didn't we check the values, guys? Nan? Why the hell is nan? Not a number. Not a number. Guys, why is this not a number? What we talked about this. It should be a number. Right. Let's get the water. Alright. Oh, the geometry. See, these are legit values. X min y min x max y max. So the spatial reference for luck. The map view, the full extent is equal to this new full extent. And that should do a trick. That should have done a trick. Did it? So, what if we did? Did we just do the same thing, guys? I was literally doing that, right? Oh, not to this extent, but oh my god! Holy crap! There's nothing called map view at full extent. Dude, it's working. I can't believe I spent 10 minutes to fucking just a stupid wrong property. Oh man, I need to get some sleep. Beautiful, guys. This is working. Give me some wind turbines. It actually zooms in. It doesn't care. Are you in what? It does not care. What spatial reference just works. So this is now, I think this is like closest to a usable software. It's getting to a usable software where you can change the basemap. You can work with your local ArcGIS server. So if your ArcGIS server is federated with Portal, that might cause you some problems because we didn't build any authentications whatsoever in this. So, but if it's a public service, you're good, right? Like that one. All of these public services are just cool. And guys, with this, I am going to leave you, and I'm gonna see you in the next one. Pool permits. Oh, that is really cool, guys. Man, it feels good to fix this finally, right? Right. Okay, guys. What do you need to see next? Right? I'm gonna check in this code in a minute. And so this episode will be available maybe sometime this week. Alright guys, you guys stay awesome. I'm gonna see you in the next one. If you like this video, just share it with people of the geo geeks out there, people who you think might this be useful to. And again, the source code is in the description, the GitHub repo. You can go by episode and look at every single line of code that we authored. I don't author anything offline, everything is recorded. And yeah guys, ask questions if you have any questions. So this was like really nasty. I didn't find any source code out there that does that, really, just to do this in a generic manner. But yeah, finally we did it. All right guys, stay awesome.